Hey, calculus folks, thanks for watching my video. I need you to understand a little bit about what Desmos is doing. So that's why I'm on this Google Chrome browser, and then we're going to Desmos. Oops, let's try that. Desmos, right? And we open up the graphing calculator, and we're going to type in here our function. Now, you're going to be assigned problem 1 or problem 3 or problem 5. So I'm not going to type in one of those specific ones. I'm going to do an easier one, like plain x squared, let's say. Okay, so let's say we had x squared here, and I wanted to know what the slope was at any one of these points. Well, Desmos will do that for us. It'll figure out the slope, and then it'll plot it as a y value. So like if we're at -2 and it comes up here and it says, oh, the slope over here is whatever, -3. It'll go -2, and then it'll put a dot right here at -3. So I go here, and then I go down here to -3. It would put a dot right down there. So let's see what it does here. You just type in f prime of x, and it graphs the derivative. All right, now if we want to evaluate that derivative at a particular spot, like let's say we do f prime at 1.5, okay, it says the slope is 3. So if I was to look at 1.5, well, here's 1, here's 1.5. I go right there to my function. My slope should be a +3. And so if I go to the blue curve, let's see at 1.5, the blue curve, sure enough, it's 3. So if I was to just put it on the screen here, if I go 1.5 comma f prime of 1.5, it's going to show us that dot, and it's going to label it, and it's going to, that 3 right there tells us the slope. Down here, let's plot that point too, 1.5 comma f of 1.5. All right, and so at 1.5 the slope is 3. It figures it out at every point on the red curve, and it tells us what that slope is. So we could change these to be sliders. Like let's make that a, let's make this a, and let's make this a, and this one a right here. And now that point will track with us, and any point I find on the red curve, I can find the slope down here. That slope right there should be a -2.6. Now, I'm not drawing the tangent line right now. That's kind of like a added layer of complication. We don't really need to see the tangent line, but you could just imagine that the slope right here, that this function's decreasing at a rate of -2.6. Okay, now I don't know what the units are on the y or the x-axis, so I'm not saying what the units would be, but the slope is -2.6. I hope this numerical derivative right here, right there, I hope I'm making that clear. That's how you calculate the numerical derivative. You just put f prime of x, and then make sure you have your function up here correctly labeled. Thanks for watching my video.